can't see it. You often can't smell it. But in the wrong concentration, it can poison a worker, ignite a process, or shut down a plant. Gas is one of the most serious hazards in any industrial facility, and the device standing between that hazard and your people is only as good as the sensor inside it. This is Gas Detection 101. By the end, you'll know which sensor technology fits which hazard and the questions to ask before you spec one. Here's the mistake we see most often. A facility buys one type of gas detector and uses it everywhere. But gas hazards fall into 3 different categories, and no single sensor handles all of them well. Get the category wrong, and the detector either misses the hazard entirely or cries wolf until people stop trusting it. The 3 categories are combustible gases, which create an explosion risk, toxic gases, which threaten worker health even at tiny concentrations, and oxygen itself, where both too little and too much are dangerous. The technology you choose depends entirely on which of these you're trying to catch. First, catalytic bead sensors. These are the workhorse for combustible gases, measured as a percentage of the lower explosive limit. Gas burns on a heated bead, and the sensor reads the temperature change. They're proven and affordable, but they need oxygen to work, and certain compounds, silicones, sulfur compounds, lead, can poison the bead over time. In those environments, you need a different approach. Next, infrared sensors. Instead of burning the gas, they shine an infrared beam through it and measure how much light specific gases absorb. Infrared can't be poisoned, doesn't need oxygen to operate, and fails safe rather than silently going dead. That makes it the stronger choice for hydrocarbon detection in tough environments or anywhere a catalytic bead would get poisoned. The trade-off is cost, and that it's tuned to specific gases rather than detecting everything combustible. For toxic gases, electrochemical sensors are the standard. Gas diffuses into a cell and creates a small electrical current proportional to concentration. These measure in parts per million, which is exactly the sensitivity you need for gases like hydrogen sulfide, carbon monoxide, or chlorine, where the dangerous level is far below anything you'd smell or see. They're specific and sensitive, but they have a finite life and need regular calibration and replacement. 2 more worth knowing. Oxygen sensors track both depletion, common in confined spaces and inerted vessels, and enrichment, which raises fire risk. And photoionization detectors, or PIDs, catch volatile organic compounds at low concentrations where other sensors aren't sensitive enough. The point isn't to memorize every option. It's to match the sensor to the hazard. So before you spec anything, walk through 6 questions. What gas or gases are you detecting? Is the hazard combustible, toxic, or oxygen-related? What concentration actually matters for that hazard? Is the area electrically classified? Are there compounds present that could poison a catalytic sensor? And do you need fixed monitoring or a portable instrument? Answer those, and the right technology usually picks itself. Here's how that looks as a decision tree. Start with the hazard. If it's combustible, ask whether poisoning compounds are present. If yes, infrared. If no, catalytic bead is fine. If the hazard is toxic, you're in electrochemical or PID territory, depending on the gas and concentration. If it's oxygen, you need a dedicated oxygen sensor. 1 question at a time, and you arrive at the right technology without guessing. One more thing that trips people up. If the gas you're detecting is combustible, the detector itself is sitting in a potentially explosive atmosphere. That means the device has to be rated for the area classification, explosion-proof or intrinsically safe, depending on the install. The right sensor in the wrong housing isn't a solution. It's a liability. Choosing a gas detector isn't about finding the most sensitive sensor on the market. It's about matching the technology to the hazard, the concentration, and the environment. We work with process and safety engineers across Tennessee, Georgia, Alabama, and the Florida Panhandle to do exactly that. If you've got a detection challenge you'd like to talk through, reach out. And if this was useful, subscribe. We cover more application guides and engineered solutions built for the people who actually have to make these calls. Thanks for watching.